All right, if you have made it through Inequality Theorem A and Inequality Theorem B, now you get to the fun stuff. We're going to take the inequalities that we just learned about in Worksheet B and apply it to some problems. So the theorem says that every side needs to be shorter than the other two added together, or the longest side needs to be shorter than the sum of the two smaller sides. Well, with a variable, maybe 13 is the longest side, but maybe x is the longest side. I'm not sure. So you have to write a couple inequalities. You have to guess maybe 13 is the longest side, and if it is, it needs to be shorter than the other two sides added together. And now let's solve this inequality. We can subtract 4 from both sides, and we get 9 less than x. Now it does make sense to have your x value on the left side. So if we want to switch the order of inequalities, we can do that, but we just need to remember to switch the direction of the inequality as well. So 9 is less than x is the same thing as x is greater than 9. But we also have to consider, well, what if x is the longest side? If x is the longest side, that would have to be less than the other two sides added together. So I get x is less than 17. So I kind of have two inequalities here, and the answer is the region where they're both true. So the way that we can sketch this, or write this inequality out, let's think about this for a second. We have 9, we have 17. X needs to be bigger than 9, so on the number line, somewhere over in that direction, but also x has to be less than 17, so on that number line we can go there. Well, the actual answer is this little area where they're both true. So x needs to be between 9 and 17. So the way that we can write that is with a compound inequality, which is more than one inequality happening in the expression. 9 less than x less than 17 is like saying x is between 9 and 17. Now you may notice something. The number 9, that comes from taking 13 minus 4, and the number 7, that we get by taking 13 plus 4. So the low end of this range of x values is the difference, or the answer from subtraction problem, of those two sides. And the high end of the range is the sum of adding those other two sides together. Let's take a look at this next example, and let's generalize here a little bit as well. So let's think of this like we thought about that last problem for a second. We know this question mark side, whatever it's going to be, is going to be sandwiched between the difference of these two, 17 minus 6 is 11, and the sum of these two, 17 plus 6, is 23. But it's not really that question mark, it is the expression 4x plus 2. So here's a little trick we can do with inequalities. We can actually manipulate these like equations, sort of like equations. There is an exception that I'll talk about in a second. But instead of just two parts, there's three expressions going on here. So there's part number 1 here, part number 2 in the middle, and part number 3 here. So whatever we do to the part in the middle where the x is, we need to do that to all three parts. So for example, we can subtract 2 from all three parts. 9 less than 4x less than 21. And then we can divide all of the parts by 4 to get 9/4 less than x less than 21/4. And that will be the answer for the possible x values in this problem here. So the last thing I want to talk about in this video is reversing the direction of the inequality. If you have an inequality where you have to divide by a negative, if you divide or multiply by a negative, the inequality changes direction. So when we divide by this negative here, then the inequality is going to pull a little switcheroo, and it's going to go from a greater than to now a less than when I divide by these inequalities. So x is less than -6. Inequalities almost act like equal signs for manipulation's sake, except if we multiply or divide by a negative, if you multiply or divide by a negative, reverse the direction. And also, and I mentioned it earlier, if you switch the left-hand side and the right-hand side of an inequality, you would reverse the direction of the inequality there as well. Because, of course, the alligator likes to eat the larger number. And when the larger number switches the left and the right-hand side, then the alligator switches to eat the larger number. Okay. So this is the kind of advanced stuff, but if you made it through the worksheets A and B, hopefully you can handle worksheet C and try some of these practice problems.